Welcome to Nabeel Math Academy. This is Dr. Mohammed. In this video, we are going to discuss about the topic optimization problem. So, what is optimization? So, optimization means to find the maximum and minimum value of the quantity or finding the maximum and minimum where it occurs. So, to prove the maximum minimum, we have the two tests. One is using the first derivative test and the second derivative test. So these are the two methods to find the maximum minimum. So using the first derivative test, what is that? We are using the f prime, that is the f prime, first derivative test. If I have to find the critical value, f prime equals 0, you will get a critical value. This is a critical value. If the sign changes from plus to minus, you will have a maximum. When you have a minus to plus, therefore it is a minimum point. Similarly, we will have the second derivative test. So what is the second derivative test? You have to differentiate the f double prime two times. So if it is f double prime is more than 0, it is maximum. This is actually minimum. So this one is, you will have less than maximum, more than minimum. So this is the condition we will have. So less than maximum and more than we will have minimum. If it is equal 0, it's a saddle point. Actually, this is the saddle point. There is no maximum minimum. This we call it as saddle point. Now next one, we will have one example to find by the maximum minimum of the function using the first derivative and second derivative. How will you find? First, you have to find the first prime f prime of x, 6x minus 6, and put it equals 0 in order to calculate the critical value. So this is the critical value, 6x equal x, x equal 1. Now using the first derivative test, I have to take f prime is equal 6x minus x. If I substitute any number in the right, you will get minus. Any number in the left, you will get plus. So actually we have to substitute these two here. You will get plus 6, and 0 as here you will get minus 6. Therefore you will have minus 2 plus. Whenever if it is minus 2 plus, what we have in the above. So in the above from minus to plus, therefore it is a minimum. So this is the minimum value using the first derivative. Now let us solve the same thing with the using second derivative. In the second derivative, we need the double derivative, that is the second prime, f double prime. So if you differentiate continuously, you will get 6. Therefore, when you substitute the critical value and the f double prime, it becomes 6, which is more than 0, which is a minimum value as per the rule. So therefore, in both the cases, you will have a minimum. Let us go to the next one, which is the application problem. So here in this question, it is asking, first understand the question what is asking here. A farmer has 1,200 meters of fencing and want to fence off a rectangular field. This is a very important information. Rectangular field that borders a straight river. He need no fencing along with the river. He need no fencing along with the river. And what is the dimension of the field that has the largest area? So here actually this is the scenario which is given, and this is a river you have. River. This is a river and this is X and Y. He don't want the fencing on the river side. So this is the scenario which is given. So my aim is to find the X and Y at the end. So since it is a rectangle, so what is the rectangle area and perimeter? So area of a rectangle is area of rectangle is given by L into B. So therefore X into Y. And what is the perimeter? Perimeter. So it is actually for the complete rectangle. So this is the area and this is the area and perimeter of a rectangle if it is complete. So let us go with this part. First I have area. So area is given by x, y. So this is x, y. And here in this question it is given the perimeter, the fencing length. So total fencing which is given in the question 1200. So what is the perimeter? Perimeter. Given perimeter which is equal to x plus y. Why we are not taking 2y? Because there is no fencing in the reverse side. That's why it is 1y. So which is given by 1200. From this I will reduce y. What is y equal? Y equal 1200 minus 2x. So I will replace the y here as the x value, this part. So therefore area of x is equal, in terms of x we will convert. So the y is 2200 minus 2x. When you multiply, you will get a is 1200x minus 2x square. Now it's a function, you can calculate the maximum and minimum is using the same above. So first I need the first derivative. What is the first derivative? 1200 minus 4x, and put it equal 0 in order to find the critical value. So I will just substitute the critical value here, 0. So you will find it 1200 minus 4. So it is 2400. So x is equal 300. X is equal 300. So this is the critical value. So what is the y value? We got the x value. What is the y value? When I substitute, so y value is 1200 minus it is 600 when you substitute x. So y value is equal 600. So this is the dimension of the rectangle field. But one thing I have to show. What is that one? It should be a maximum, the larger area. For that one, I will make use of the second derivative. When you differentiate the second derivative, what happened this part? F double prime of x is equal, it is minus 4x. So this is minus 4. So therefore it is less than 0. Whenever less than 0 second derivative, it is a maximum. It's a maximum. This is what I have to show. So this dimension has the maximum area. Now the next one is similar to this one. Find the dimension of a rectangle. It's the same rule. The perimeter is given by 100 meters, whose area is a larger. Whose area is a larger. Is the same thing, is given direct without any application, is given directly. So there are x, y. So here y, here also x. So is the same rule, we will write it. The same rule. First of all, I will take this part is given. What is given? Perimeter is given. Perimeter is 100 meters. So what is the perimeter here? You have complete area. You will have a 2x and 2y. But in the last problem, you have a one side as a river, which as mentioned in the question, that's why we are not taking y. But here 2x plus 2y equal 100. So I will convert in terms of 100. So what happened? 2x, and 2 is a common factor. So if you take common, you will get here 50 minus x into 2y. So here 2 with the 2 cancel. Y is equal 50 minus x. Now coming to the area. What is the area? It is xy. So I just replace the y as in terms of x. What is the y here? So it's 50 minus x from this side. Now when you multiply this part, you will get 50x minus x square is the same rule. I have to find the critical value. 50 minus 2x. So put it equal 0. 50 minus 2x and 2x equal 50. X is equal 25. X is equal 25. Is a meter is given the unit meter. And what about the y value? When I substitute in y, you will get y equal 50 minus 25, which is equal 25. So if you have an equal length, the side, the length and the breadth, therefore it's a square. 25 into 25, therefore it's a square. So 25, here you have 25, it's a square, not a rectangle. Now I have to show this one, it should be a maximum. I have to show it is a maximum. How will you show? So just I will take the second derivative. What is the second derivative for this part? Which is equal minus 2, which is less than 0, which has the maximum by using second derivative test. So this is the difference between the last problem and this problem. Now here there are some questions they will ask like this. Find two numbers whose difference is 100, and whose product is minimum. Whose product is minimum. Let us, I am taking this one as, let x and y be the two number. And what is given here? What is given here? They are giving the difference. The difference of these two is 100. So I will take y minus x is equal 100, which is given. Which is given in the question. And what is the next one? It is given here. The product is maximum. So I will show the function f of x is equal the product. This is a product. So from this I will reduce y. Y equal 100 plus x. So I write it here. X 100 plus x is the same rule. I multiply inside first. I multiply inside the x value. So what will you have? 100x plus x square. Now start the differentiation. What is the differentiation here? It is 100 plus 2x. Put it equals 0. So move it here. 2x equal minus 100, and which in turn implies x is equal minus 50 is the first number. And what about the y value? If I substitute the y here in this y, so you will get 100 minus 50, which is equal plus 50. So y value is 50, x value is minus 50. But I have to show one more thing. What is that one? Minimum. So take the first derivative. What is the first derivative? You have 100 plus 2x. I differentiate second time. You will have 100 becomes 0. You will get 2. So since it is positive more than 0, which is minimum as per the second derivative test. So second derivative test is a very easy when compared to the first derivative. So always use the second derivative test to show maximum and minimum. And the last problem of this topic is the farmer wants to fence an area of. Since the area is given in the last two problem, if you notice, you will have the perimeter. But here is the area is given. In the rectangular field, this is important information. And it is divided into half with the fencing parallel to each of the sides of the rectangle. How can he do this so that the minimum cost of the fencing is done? So actually this is a complete rectangle. There is no river or something, it is mentioned in the question. So it is completely rectangle. So it is x and this is y. And it is divide into half. This is a very important information we have. So it is divided into the half. So you will have 3x side and you will have 2y side. 2y side. So let us go with this part. So given, I write it here first, given area which is given by 10,000, 15,000, 15,000. So that is the xy is given. Xy is 15,000 is given. From this, I can write it as y equal 15,000 over x. So now go to the parameter. So perimeter of the rectangle is given by. So how many function? How many the function? The x. How many x you have? 3x. So I will write it 3x plus 2y plus 2y. Now replace the y is equal this part. Replace y equal this one. So here you will have 3x plus 2 times of it is 15,000 over x. Now if you simplify, you will get 3x plus 30,000 over x. So this is my f of x. Now to start the differentiation. So what is the first differentiation? F prime is given by 3. So 30,000 is a constant. What is the differentiation of 1 over x? Is the same rule. What we have? X to the power minus 1 minus 1 to the power minus 2. If you bring it down, you will get x square. So this is a y and this is a y prime. So it's the same thing, we will do it. So you will get minus 1 over x square. Minus 1 over x square. Now simplify this part. So you will have 0, put it 0. You will get 3 minus 30,000 over x square. Move it here. So it becomes 30,000 over x square equal 3. Now cancel. What happened here? One time this is 10,000. When you take a square root, you will get x square equal 10,000. So x is equal 100. X is equal 100. So this is what you will have. Now I will calculate the y. What is the y value here? Y equal 15,000 over 100. So 2020 cancel. Y equal 150. So this is the dimension of the rectangle so that the minimum costing of the fencing is done. But we have to show minimum. So for the showing minimum, I will take f double prime. So how will you calculate f double prime? This is the f prime. So 3 becomes 0. This is 0 plus this is actually minus. So minus the 30,000. So what is the derivative of 1 over x square? So it's a 1 over x square is the same rule I am taking here. I will take, what is 1 over x? How will you take 1 over x square? So x power minus 2. Bring it here, x to the power minus 3. Move it down, minus 2 over x power 3. So therefore the derivative is minus 2 over x power 3. When you multiply, you will get 60,000 over x power 3. So whatever be the value, this become more than. Therefore, it's a minimum area. Thank you.